Welcome to today's design tutorial. In this video, we're going to walk through the complete 3D modeling process of an electric bike battery pack using SolidWorks. We start with the core of the pack, the battery cells. Here, we're utilizing standard cylindrical lithium-ion cells. We've already set up the base structural holder, so we'll begin by inserting the remaining cells into their designated slots. This holder is designed to ensure proper spacing for heat dissipation and structural integrity during the ride. Once the cells are securely in place, the next critical step is establishing the electrical connections. We insert the double strip components into our assembly. These represent the nickel strips that will eventually be spot welded to the cells, connecting them in specific series and parallel configurations. We use the mate tool in SolidWorks to precisely align these strips over the positive and negative terminals. Accurate placement in the CAD model is crucial, as any misalignment here can lead to major issues during physical assembly. To ensure these connections don't shift under vibration, we add small fixation clips. With the connections on one side secure, we move around the assembly to build up the surrounding casing. Thermal management is vital for high-performance e-bike batteries. To address this, we insert a 2 mm thick thermal pad over the cell connections. This pad will safely transfer heat away from the cells. Over the thermal pad, we place a 2 mm aluminum sheet, which acts as an effective heat sink, spreading the thermal load evenly. Now, we need to scale up our design. We duplicate our completed module to increase the overall voltage and capacity of the battery pack. We stack a second module on top of the first, carefully aligning the internal structures. Once stacked, we go through the meticulous process of adding the nickel strips to connect this new upper layer. To speed up this repetitive process, we utilize the linear component pattern feature, allowing us to rapidly duplicate and place multiple identical strips across the entire cell array. With all the internal cell connections complete, we shift our focus to finalizing the protective casing. This enclosure needs to be robust to protect the volatile cells from impacts, moisture, and dust. We model the sidewalls, ensuring there's adequate internal clearance for the final wiring harness and battery management system. After verifying all internal clearances and overlaps, we carefully position the top cover, snapping it into place to fully seal the internal components. The final step is to add the main power output connectors. We are using standard Anderson power pole connectors, a red housing for positive and a black housing for negative. We precisely mate these connectors into the pre-designed cutouts on the side of our casing. These will provide a secure, high-current connection to the e-bike's motor controller. And there we have it, a fully designed, structurally sound electric bike battery pack. Thank you for watching. If you found this tutorial helpful, be sure to like and subscribe for more CAD design content.